There's a wire running from point A to point B, and it is connected with many capacitors and many resistors. What we want to do in this problem is to simplify this system into a single capacitor that is equivalent to the capacitance of this system of capacitors, and a single resistor that has the resistance equivalent to this system of resistors. So we can begin by finding a capacitance that is equivalent to this system of capacitors. And C1 and C2 are joined in series. So the series capacitance equivalence relation is given by 1 over Ct equals 1 over C1 plus 1 over C2, and so on if we have more capacitors. But here we only have 2 capacitors, so this is sufficient. So to find the total capacitor, total capacitance for C1 and C2, we plug C1 here and get 1 over 1 microfarad, and 1 over C2, which is 1 over 2 microfarad. So this is equivalent to 1 over 1 plus 1 over 2 microfarad, and that is simply 1 plus 1 half, and that's 3 over 2 because that's 1 half, 1 and 1 half. And so that's 3 over 2, I should say it's microfarad to the negative 1, 1 over microfarad, and in the end we get Ct equals to the inverse of this, which is 2 over 3 microfarad. So what this says is we could replace these 2 capacitors with a single capacitor that has a capacitance of 2/3 microfarad. So for next we can find a capacitance equivalent to C3 and C4, and they're joined in parallel, and for parallel capacitance we have this relation, Ct equals C1 plus C2, and so on. So in this case we have C3 and C4, and that's 3 microfarad plus 4 microfarad, and that is equal to 7 microfarad. So now we have C1 and C2 equivalent to 2/3 microfarad, and C3 and C4 equivalent to 7 microfarad. So now we have 2 capacitors joined in series again, and we can use this relation to find the equivalent capacitance. So we have 1 over 2 over 3 microfarad plus 1 over 7 microfarad, and we can rewrite this fraction into 3 over 2 times 1 over microfarad plus 1 over 7 microfarad. So to further simplify this expression, we can find a common denominator for both fractions, and so they don't have any common multiples, so we multiply the denominator from the other. So we have 7 over 7 times 3 over 2 microfarad plus 2 times 1 over 2 times 7 microfarad, and that is 21 plus 14 microfarad plus 2 over 14 microfarad. So now we have a common denominator, and we get 23 over 14 microfarad. So next we find a resistor equivalence. So first we begin with this system of resistors, because there is nothing to add to R3 before we find a common resistor to add to R3. So the parallel resistance relation is given by 1 over RT equals 1 over R1 plus 1 over R2, and so on. So we have 1 over RT equals 1 over 1 ohms plus 1 over 2 ohms. And we get something similar to the series capacitors. So we have 1 plus 1/2 times 1 over ohms, and that's 3 over 2 times 1 over ohms. And so the resistance is 2 over 3 ohms, similar to the capacitance. So next we can rewrite this system of resistors into a single resistor with 2 over 3 ohms as the resistance and 3 ohms for R3. So we have RT equal to, before I do that, I should mention the series resistance is given by by RT equals R1 plus R2, and so on if we have more. But now we only have 2 resistors, so the equivalent resistance is given by 2 over 3 ohms plus 3 ohms. And to get a common denominator, we multiply 3 over 3 to the 3 ohms. And we get 2 over 3 ohms plus 9 over 3 ohms. And that is 11 over 3 ohms. So in the end we have a single resistor with 11 over 3 ohms. And we can rewrite the system that we were given with as 11 over 3 ohms and 23 over 14 microfarad.